In 1966, a program called ELIZA was created by Joseph Weizenbaum. It was the first chatbot and worked like a therapist by turning people's statements into questions. For instance, if you said, "I'm feeling sad today," ELIZA would respond, "Why are you feeling sad today?" It didn't actually understand anything, it just flipped statements into questions. Nowadays, there is this engineering and architecture firm called Suico. They created a conversational AI called Suico GPT, which goes way beyond what ELIZA could do. Suico GPT is built to help engineers, and it can answer complex questions. For example, an engineer could ask, "What's the best material for this bridge foundation?" In seconds, it could analyze soil data and recommend the most cost-effective and sustainable strategies. So the journey from ELIZA to Suico GPT shows just how far AI has come, especially with these large language models, or LLMs. And Suico GPT is just one example. There are so many more applications out there, each tailored to different industries and needs. Therefore, for today's business managers, the question isn't whether they can benefit from LLMs, but how they can implement these tools to transform their operations. So how language models have evolved, and what are the strategies managers can adopt to integrate them successfully? Stay tuned, because today we are looking into that. I'm Hamid Nash, and welcome to a new episode of eCompass. LLMs, or large language models, are AI systems designed to understand, generate, and manipulate human language. The journey started with ELIZA, as we mentioned earlier, which was a major step in the evolution of conversational AI. So after ELIZA, we entered what we can call the rule-based era of conversational AI. In the 70s and 80s, researchers developed systems that could respond to specific commands using predefined rules. For example, programs like Shredlu could understand and execute simple instructions. For instance, you can ask it to pick up the red block and it would respond by moving a virtual block. But these systems had limits, as they only worked within predefined rules and struggled with anything that was unexpected. Then in the 90s, AI moved into the era of probabilities. Models started predicting the next word in a sentence based on how often certain words combinations showed up in the data. For instance, in a trigram model, which looks at groups of 3 words, if it sees New York, it would predict city as the next word, rather than something random like banana, because New York City appears much more frequently in the text. So while these models could make decent guesses, they were limited as they were based on how frequently words combinations occurred in the data. But the year 2000, we entered the era of neural networks. This is when AI began to understand relationships between words and keep track of context in a sentence. Then in the year 2013, researchers figured out something brilliant. They could represent words as numbers, and these numbers were called embeddings. Embeddings are a way to turn words into numbers so that AI can apply some math and understand their meaning. For example, instead of just treating king as a word, they could represent it as a group of numbers that captured its meaning. So words with similar meanings would have quite similar numbers. So king and queen would be close together, while king and a bicycle would be far apart. What's interesting is that these embeddings could capture relationships. For example, the numbers could show that king is to a man what queen is to a woman. 2017 marked the beginning of the Transformer era. This was literally a revolution in how AI understands language. Think of how humans read a sentence. We don't just look at one word at a time and forget the rest. Instead, we understand the entire sentence by connecting all the words and their meanings. Earlier AI models didn't do this, as they processed words in order, one after another, without seeing how they relate to each other as a whole. It's like it was trying to read a long document with a tiny flashlight, seeing just one word at a time. By the time it reaches the end, it forgets what was at the beginning. So with the help of transformers, AI can now see and understand the whole document at once. Let's take this example where an AI is asked to translate this sentence. The pitch was perfect. Earlier, AI might struggle to determine the meaning of pitch. Does it refer to a business proposal or a musical note? With transformers and their attention mechanism, AI now can analyze the context of the entire document and understand that in a business meeting, pitch likely refers to a presentation or proposal. 2018 marked the beginning of a truly large language models. Google introduced BERT and OpenAI released their GPT series. In November 2022, OpenAI released ChatGPT, a chatbot built on fine-tuned version of GPT-3 that writes essays, answers questions, and generates code from simple instructions. What made ChatGPT stand out was how it was trained. First, it learned from massive amounts of data, giving it the ability to understand and generate text that sounds natural. Then it was refined further using feedback from thousands of experts. During this time, we also saw the rise of AI models that can create images like DALL-E and Midjourney, and videos like Runway and Pika Labs. Now, new platforms are capable of generating not just text and images, but also complex code, infographics, slides, voiceovers, and synthetic speech, music, and other created content. So the evolution from ELIZA to these highly advanced LLMs shows how far AI has come. For organizations, this shift isn't just fascinating, it's a call to action. So the question isn't whether they should adopt these tools, but how to integrate them. So, what does it take to implement a large language model? Now, implementing an LLM starts with focusing on the essentials. The model itself, the data it needs, the infrastructure to support it, and the implementation approach. And most importantly, a clear business purpose it will serve. The first step is understanding why you're implementing an LLM. Are you looking to drive innovation or improve efficiency? If it's about innovation, the goal might be to create new capabilities or services. And if it's about efficiency, it may be for automating tasks or saving time or resources. At the core of an LLM implementation lies the selection of a foundational model. This is what powers the system. Foundational models are trained on mountains of data, and they are two types: proprietary and open source. Proprietary models are ready-to-use solutions. Think GPT-4o or Claude AI. They are developed by major tech companies and come pre-trained and refined with human feedback. But here's the catch. They're like a black box. We know they work well, but the companies don't reveal exactly what data they use for training. And let me tell you about the resources needed to build these models. It's mind-boggling. We're talking about investments in the hundreds of millions of dollars and computing power. Thousands of GPU clusters running non-stop for weeks. So definitely it's far beyond a garage project. And on the other hand, you've got open source models like Llama 3. The code is available and can be adjusted to suit the needs of a company. But here's something important to understand about both types of models. They are generalists. That means they are really good at general tasks, but they can struggle when it comes to specialized industry needs, like in energy or pharmaceutical. Why? Well, either the training data they used might not include enough of that specific knowledge, or simply because they don't have access to private data from companies. So this can make it tricky for certain industries to fully rely on them without extra customization. So how do you take these powerful but general models and make them work for your specific needs? There are typically four main approaches. The simplest one is in-context learning, or ICL. Let's say your company has access to Claude AI through a business account with an API access. Now, if an employee asks Claude AI, I want to reset my password. Claude doesn't know your company's specific password reset process, and that's where ICL comes in. The idea is to build a system and host it either locally or on the cloud that adds context before sending questions to Claude. Claude then processes this enhanced prompt and send back the response to your system, which send it back to the employee. This approach is cost-effective since it only requires a subscription and the development of a separate system to add context to the user requests. Second, there is the RAG approach. RAG stands for Retrieval Augmented Generation. Think of it as a search engine for your business documents. So just as in the in-context learning, your system not only adds context to the user's query, but also looks for the most relevant information from your text files, PDFs, or web pages. So your system takes the user query, add context, and the extracted paragraphs and links, and send the query to the LLM, which obviously processes it and delivers a response back to the system, and finally to the user. RAG is ideal for tasks that require up-to-date information and data that is constantly evolving, like product specs, pricing, or company policies. Third, there's the fine-tuning approach. Fine-tuning is like giving the LLM an advanced course on your company's specific expertise. The idea is to take a model like GPT or Claude and train it further with specific examples of the inputs and outputs you want it to learn. This process uses supervised learning, where you provide the model through its API hundreds or even thousands of inputs and outputs pairs. These pairs could be text or even images, depending on the task. In HR, for example, a dataset may include examples like those shown in this dataset. By processing thousands of these examples, the model becomes capable of handling HR-related queries with accuracy. After fine-tuning, you can connect the customized model through an API and plug it right into the company's systems. It can then help with tasks like answering questions about the policies about your company. Finally, we have the continued pre-training. This is like sending your LLM back to school, not to start from scratch, but to master a new subject. Instead of teaching it specific responses, you let it immerse itself in a ton of text from a specific field, kind of like reading every book in the library about one particular topic. It's usually unsupervised learning and deals with different types of data. For example, if you are in energy, you might pre-train your model on technical manuals or research papers on renewable energy technologies. This method changes the model's parameters to suit knowledge specific to your company's industry. A good example is Llama 3, which can be pre-trained to excel in niche areas. However, continued pre-training requires even more resources than fine-tuning. Think massive datasets, advanced infrastructure, and significant budget. It's powerful, but not always practical for every organization. So how do you choose between these approaches? This is where we need to think about your data characteristics. First, consider your data stability. Is your information relatively stable, or does it change frequently? For stable data, fine-tuning or continued pre-training might make sense. The choice between these two approaches is largely determined by cost. But if your data is constantly updating, like product catalog or market information, RAG or in-context learning would be more appropriate. Privacy is another factor. With fine-tuning and pre-training, your data becomes parts of the model parameters. If sensitive data is involved, fine-tuning or pre-training on secure or private infrastructure might be more suitable to maintain control over your information. And when it comes to running AI models, there are typically two options. Either you can keep everything in-house or use the cloud. Running it in-house means you control everything, which is great for sectors like healthcare, where privacy is important, or the cloud option. Think Amazon or Microsoft. They provide all the necessary tools, including pre-trained LLMs, RAG, and search tools. There are also many companies that go in both. They keep sensitive data in-house while using the cloud for everything else. Finally, the risks of LLMs should be tackled. But it's beyond the scope of this episode. We can cover it in the future. But here's the thing. AI has still two big issues. First, hallucination, as LLMs sometimes just make things up, like fake research papers or court cases, which is a real problem for serious work. Second, bias, as AI can pick up hidden biases from the data it's trained on, leading to unfair or unethical outcomes. To handle this, you need a few safeguards like fact-checking and doing regular system checks. And these steps help keep LLMs on track and more reliable. So as we wrap up this discussion, remember that implementing LLM is a journey, not a destination. Of course, technology keeps evolving, and so should your implementation. Start with clear understanding of your needs, start with small-scale project, choose your approach, and always keep user needs and safety in mind. I'm Hamid Nash, and see you in the next episode of eCompass.